In this video, we are going to discuss about electric field intensity. On completion of this electric field intensity, students will be able to discuss the behavior of this electric fields. In electric field intensity, you are considering a point charge Q1 and another one point charge Q2. So if this point charge Q2 is brought near to this Q1, they are experience some kind of force. In fact, if Q2 is moved around this Q1 charge means also still this Q2 charge will experience a force. So that region we will be saying as electric field. So the force experienced by the charge Q2 due to this Q1 charge, we can write it as F vector is equal to Q1 Q2 divided by 4 pi epsilon naught into R square into AR square. So we know force per unit charge is nothing but electric field, or we call it as electric field intensity or electric field strength. So F2 divided by Q2 is equal to Q1 divided by 4 by epsilon naught or 12 square into A12 vector. So we can represent this vector in coulomb. If you are considering a charge Q1 and the unit positive charge Q2 as 1 coulomb, the force acting on the Q2 due to this Q1 will be along the unit vector. We can write this equation as E vector is equal to Q1 divided by 4 pi epsilon into R square into AR vector. In case of spherical system means we can write it as E vector is equal to Q1 divided by 4 pi epsilon naught into small r square into AR vector. Since we are considering here the radius of the sphere as small r. And the unit of this electric field intensity is force per unit charge. So we can write it as newtons per coulomb, or we can measure this electric field in volts per meter. And if you are finding out this electric field in Cartesian system means we can consider the charge Q1 and the location as x, y, z. So here 5 steps we have to take it. That is, first step we have to find out the position vector, and the second step we have to find out the distance vector. Third step we have to find out the unit vector. Fourth step we will be calculating the electric field. Then fifth step, with this electric field we will be finding out the magnitude value. So based on the 5 steps we will be finding out the electric field. In case if there is more than 2 point charges means we will be calculating the force from these number of charges. So this number of charges is the vector sum of the individual force which is exerted by the each charges. We can represent this as E vector is equal to E1 plus E2 plus E3 plus up to the number of charges present. So up to En. So E vector is equal to 1 divided by 4 pi epsilon naught into summation I is equal to 1 to n Qi divided by Ri square into Ari. So here R represents the position vector. And the major observation things which we have to note here is this electric field around this charge Q1 is directly proportional to the charge which is present in the Q1, and also this electric field around this charge Q1 is inversely proportional to the distance between these charges. So this electric field intensity at any point and this force exerted on this charge should be placed in the same direction. And also if you are placing any unit charge means then this unit charge will detect the presence of the electric field. So without this test charge we cannot find out the presence of electric field. Then this test charge if you are placing here means it should be very small enough so that this electric field intensity which we are measured will not get disturbed. And here in this electric field intensity, if you are using more than 2 point charges mean we will be using the principle of superposition. So we will be using the principle that is total forces exerted is the vector sum of the individual forces exerted by each charges. So we can represent it as E vector is equal to 1 divided by 4 pi epsilon naught into summation I is equal to 1 to n Qi divided by Ri square into Ari vector. Here one problem is given. A charge Q1 of 2 microcoulomb is located at the point P1 of 0, 0, 0, and the second charge is 3 microcoulomb at P2 is equal to -1 2, 3, and we have to find out the value of electric field. So first we will be calculating the position vector r vector. So 2 point charges are given, so we will be calculating the point position value, then we will be applying it on the unit vector. So from that we will be substituting on the electric field. So electric field equation we know, that is 1 divided by 4 pi epsilon naught into q1 divided by r1 square into a1 square. So from that we know the value of r value, then we know the value of unit vector. So every value we will be substituting here, and we will be finding out the value of electric field. Then electric field due to continuous charge distribution. So here in this continuous point charge distribution, there are 4 types of charge distribution. That is, first one is point charge, second one is line charge, third one is surface charge, and fourth one is volume charge. In case of point charge, we have the location, but there will not be any dimension. So dimensions will be very small in the case of point charge. So this point charge will be having the position where it is located, but we cannot mention the dimension, or we cannot represent the size of the point charge. And in case of line charge, we can write it as, that is rho L. So charge density of the line charge we will be writing rho L is equal to total charge which is present in coulomb divided by the total length we are expressing in meter. And here it is possible that charges will be spreaded along the line. So uniformly this charges will be distributed along this line, so we will be calling it as line charge. And here if you are finding out the value of Q, means Q is equal to rho L into dl. So Q is equal to integral of rho L dl we will be writing for finding out the line charge density. And in the case of surface charge, means if this charge is distributed uniformly along the 2-dimensional surface, means we will be calling that as surface charge, or we can call that as sheet of charge. So this 2-dimensional surface has area in square meters. So we can write this as rho S. So rho S is equal to total charge in coulomb divided by total area in square meter. Here if you have to find out the charge from Q rho S, means we will be using the formula, that is Q is equal to integral of rho S into ds. So we will be applying the value of rho S here, that we are calling as surface integral. And next one is volume charge. So volume charge, if this charges is distributed in the volume, means we will be calling it as volume charge. So this volume charge density we are denoting as rho V. Rho V is nothing but total charge in coulomb divided by the total volume in cubic meter. If you want to find out the charge, that is Q, means Q is equal to integral of rho V into dV. Quiz questions on electric field intensity. What units are used to measure the forces of an electric field? Answer is volts per meter. Second one, given 3 positive charges Q1, Q2 and Q3 that form a triangle, so the force experienced by the Q3 will be 0. Third one is, what happens when 2 like charges are placed near to each other? So like charges means it will repel each other. Thank you.